So, you've probably heard a lot of talk about processors lately. We're not just talking about the main brain of your computer, the CPU. We're diving deeper into the specialized chips that make everything from your favorite video games to the smart features on your phone possible. These are the unsung heroes working behind the scenes, processing massive amounts of data in the blink of an eye. In today's tech world, two names keep popping up more and more: GPU and NPU. They might sound like a random jumble of letters, but they are fundamentally changing how we interact with our devices and what those devices can do for us. It's a showdown of silicon, a battle for processing supremacy in very specific, very important areas. Understanding these chips is no longer just for the super tech savvy or the hardcore PC builders. It's becoming essential for everyone. Why? Because the performance of your next smartphone, the intelligence of your smart home devices, and the smoothness of your gaming experience all depend on them. These processors are the engines driving the future of technology, from stunningly realistic graphics to artificial intelligence that can write an email or edit a photo for you. As we move into an era where AI is integrated into nearly everything, knowing the difference between a GPU and an NPU helps you understand what you're actually buying and what you can expect from your tech. This isn't just about which one is better in a general sense. That's like asking if a race car is better than a dump truck. It really depends on what you're trying to do. The GPU, or graphics processing unit, has been the king of visual tasks for decades, but it also found a new life powering the first wave of the AI revolution. Then there's the NPU, the neural processing unit, a chip designed from the ground up specifically for AI and machine learning tasks. It's built for a different kind of thinking, a different kind of workload. The distinction between them is becoming more important every single day. So, let's break it down. We're going to look at what each of these processors is, what makes them tick, and where they shine. We'll explore their unique designs, their real-world applications, and how they are individually shaping the future of everything, from gaming to artificial intelligence. By the end, you'll have a clear picture of this ultimate showdown between the graphics veteran and the AI newcomer. It's a fascinating look at the hardware that powers our digital lives, and it's a story that is still being written as technology continues to evolve at an incredible pace. Let's get into it. Let's start with the one you've probably heard of, the GPU, or graphics processing unit. For a long time, its job was right there in the name. It was all about graphics. Think about a modern video game. You have millions of pixels on your screen, and each one needs to be calculated for color, light, and position, many times every second. Your computer's main processor, the CPU, is great at handling a few complex tasks one after the other, but it would choke trying to handle millions of simple, repetitive tasks all at once. That's where the GPU comes in. It's designed to do exactly that. A GPU is what's known as a parallel processor. Imagine you have one brilliant mathematician, the CPU, who can solve incredibly difficult problems one at a time. Now imagine you have 1,000 students, the GPU, who can each solve a simple math problem at the same time. If you need to solve one very hard problem, you go to the mathematician, but if you need to solve 1,000 simple problems as fast as possible, you give one to each student. That's the core idea behind the GPU. It's built with thousands of smaller, simpler cores that can all work together on a single, massive task that can be broken down into smaller pieces. This architecture makes it the perfect tool for rendering graphics. Every frame in a video game or a 3D model is essentially a massive set of simple calculations. The GPU can assign these calculations across its many cores, getting the job done almost instantly. This is why upgrading your GPU or graphics card is the single biggest thing you can do to improve your gaming performance. It allows for higher resolutions, smoother frame rates, and more complex visual effects like realistic lighting and shadows. Without the powerful parallel processing of a GPU, the immersive, photorealistic worlds we see in games today simply wouldn't exist. But the story of the GPU doesn't end with gaming. Researchers in other fields, particularly in science and finance, looked at the GPU's massive parallel processing power and had a realization. Many of their complex simulations and data analysis problems were, at their core, just like graphics, rendering, a huge number of relatively simple calculations that needed to be done at the same time. This led to the rise of GPU, or general-purpose computing, on graphics processing units. Suddenly, this chip built for making games look pretty was being used to model climate change, analyze financial markets, and, most importantly, train artificial intelligence models. Now let's talk about the newer player in the game, the NPU or Neural Processing Unit. As artificial intelligence started to become more and more common, especially on devices like smartphones, tech companies realized something. While GPUs were pretty good at handling AI tasks, they weren't perfect. They were like using a powerful adjustable wrench for every single job. It works, but it's not always the most efficient tool. AI workloads, specifically the kind used in machine learning and neural networks, have a very particular set of mathematical operations they need to perform over and over again. So, the question was asked, what if we built a chip specifically for that? And that's exactly what an NPU is. It's a purpose-built processor designed from the ground up to accelerate AI and machine learning tasks. Its entire architecture is optimized for the kind of math that neural networks rely on, which is mostly matrix multiplication and other related operations. Think of it this way. If a GPU is a team of students good at basic math, an NPU is a team of specialists who have trained their entire lives to do one specific type of advanced calculation incredibly fast and with very little effort. This specialization is the NPU's superpower, allowing it to perform AI tasks much more efficiently than a GPU. The key advantage here is efficiency, especially when it comes to power consumption. A GPU can run AI models, but it uses a lot of energy to do so because it's a large, powerful chip designed for high-performance graphics. That's fine for a big desktop computer plugged into the wall, but it's a huge problem for a smartphone that needs to last all day on a small battery. An NPU can perform the same AI calculations using a fraction of the power. This is why you see NPUs popping up in almost every new flagship smartphone. They handle features like real-time language translation, photo enhancement, and voice assistance without draining your battery. So, the NPU exists because of the explosion of on-device AI. We want our phones, laptops, and even our cars to be smarter, but we don't always want to rely on sending data to a powerful server in the cloud to get an answer. We want the intelligence right there, on the device, working instantly and privately. The NPU makes this possible. It's the dedicated brain for all things AI, handling the complex neural network processing locally, quickly, and efficiently. It represents the next step in specialized computing, moving beyond general-purpose chips to hardware designed for the specific demands of the modern AI-powered world. When you look at the fundamental design of a GPU and an NPU, you start to see why they excel at different things. It all comes down to their internal architecture. A GPU, as we've discussed, is built for massive parallelism. Its design features thousands of relatively simple processing cores. These are often grouped into larger units, but the core principle is to have a huge number of workers ready to tackle a divisible task. The GPU also has a large amount of very fast memory called VRAM, connected by a very wide memory bus. This is crucial for graphics as it needs to constantly access and manipulate large texture files and frame data. The architecture of a GPU is flexible by design. While it's optimized for graphics, its cores are programmable and can be adapted to a wide range of tasks, which is why it became so useful for general-purpose computing and early AI research. Think of its cores as being able to handle a variety of simple math problems. This flexibility is a great strength, allowing it to be a jack-of-all-trades in the world of parallel computing. However, this flexibility also means it's not perfectly optimized for any single one of those tasks. There's some overhead involved in managing all those cores and making them do things they weren't originally built for. The NPU, on the other hand, throws some of that flexibility out the window in favor of extreme specialization. Its architecture is not about having thousands of general-purpose cores. Instead, it often features what's called fixed-function hardware. These are circuits physically designed to do one thing and one thing only: the specific mathematical operations that form the backbone of neural networks, like matrix multiplication and convolutions. It's less like a team of math students, and more like a custom-built high-speed calculator designed for a single complex formula. It can't do other types of math, but it can solve its one formula at blinding speed with minimal energy. This specialized design leads to a huge leap in performance per watt, which is the key metric for mobile and edge devices. Because the NPU's circuits are purpose-built, they complete their tasks with fewer steps and less wasted energy compared to a GPU's more general-purpose cores. An NPU's architecture is all about data flow, efficiently moving data through its dedicated processing engines. It's a fundamentally different approach. The GPU is a powerful, adaptable workshop with many tools, while the NPU is a highly optimized, automated assembly line built for a single-product AI inference. This architectural difference is the very heart of the GPU versus NPU debate. So, where do you actually encounter these processors in your daily life? Well, let's start with the GPU. The most obvious place is in any device used for gaming. Your PlayStation 5, your Xbox Series X, your Nintendo Switch, and of course your gaming PC all have a powerful GPU at their core. It's the component responsible for drawing the beautiful immersive worlds you play in. Beyond gaming, GPUs are in any laptop or desktop computer. Even if you don't have a high-end graphics card, your computer's main processor has a smaller integrated GPU, an iGPU, to handle basic tasks like displaying your operating system and playing videos. But the GPU's reach, honestly, extends far beyond what you see on your screen. In the professional world, they are indispensable. Video editors, 3D animators, and architects rely on powerful GPUs to render their complex projects in real time. In the world of science, massive supercomputers are often built using thousands of GPUs working together to simulate everything from protein folding for drug discovery to the collision of black holes. And of course, GPUs are the workhorses of the cloud. When you use a cloud gaming service or a powerful online AI tool, you are essentially renting time on a massive GPU in a data center somewhere. Now let's look at the NPU. Its domain is primarily the world of smart, portable, and edge devices. The most common place to find an NPU is inside your modern smartphone. In an iPhone, it's called the Neural Engine. In Google's Pixel phones, it's part of the Tensor chip. In Android phones with Qualcomm chips, it's part of the AI engine. This NPU is working silently in the background to power a ton of features. It helps the camera recognize scenes and faces to optimize photos, enables real-time transcription of your voice messages, and powers augmented reality filters on social media apps. But NPUs are spreading far beyond just phones. You'll find them in smart home devices like smart security cameras that can tell the difference between a person, a pet, and a passing car, reducing false alarms. They are becoming critical in modern cars, powering advanced driver assistance systems, ADAS, that analyze sensor data to help with lane keeping, adaptive cruise control, and emergency braking. They're also in drones, smart speakers, and even some high-end laptops where they assist with tasks like background blur on video calls and improving battery life by handling certain tasks more efficiently than the CPU or GPU. The NPU is the champion of on-device, low-power intelligence. The story of modern AI is impossible to tell without talking about the GPU. In the early 2010s, AI researchers, especially those working on deep learning, had a breakthrough. They discovered that the architecture of a GPU, which was originally designed for parallel graphics processing, was actually incredibly well suited for training the massive neural networks their models required. Training an AI model means feeding it enormous amounts of data and making, honestly, millions of tiny adjustments to its internal parameters. This process is mathematically a series of massive matrix operations, exactly the kind of parallel workload a GPU just excels at. This discovery really kicked the AI revolution into high gear. Suddenly, training times for complex AI models went from months or years down to weeks or even days. This enabled the development of models that were bigger and more capable than ever before. The image recognition, natural language processing, and generative AI technologies we see today, like ChatGPT or Midjourney, were all born in this era. They were trained on massive clusters of powerful GPUs running for thousands of hours in data centers. The GPU became the essential tool for AI research and development, the hardware that made the impossible possible. It honestly wasn't even designed for it, but its parallel nature made it the perfect engine for teaching machines. However, there's a big difference between training an AI and using an AI. Training is the incredibly intensive process of creating the model, which is usually done in the cloud on powerful servers. Using the AI, a process called inference, is when the trained model makes a prediction or performs a task based on new data. This is, for example, what your phone does when it recognizes your face to unlock. While GPUs are great for training, they can be overkill and honestly pretty power-hungry for inference, especially on a small device. This is where the NPU steps in to continue the AI revolution. The NPU is the hero of AI inference. It's designed to run pre-trained neural network models with maximum efficiency. While the GPU did the heavy lifting to create the model in the data center, the NPU allows that model to run directly on your personal device without killing the battery or needing a constant internet connection. This enables a whole new class of edge AI applications that are faster, more responsive, and more private, because the data doesn't have to leave your device. The GPU started the AI revolution by making training feasible, and the NPU is now democratizing it by making powerful AI accessible everywhere, on every device. When it comes to gaming and high-end graphics, the GPU is still the undisputed king, and honestly, it's not even a contest. The very architecture of a GPU is custom-built for the demands of rendering complex three-dimensional scenes. It needs to handle geometry, textures, shaders, and lighting for millions of pixels, all while maintaining a high and stable frame rate. This requires the immense, flexible parallel processing power and the high-bandwidth memory that GPUs provide. An NPU with its specialized fixed-function hardware for AI math just isn't designed to handle this kind of diverse and graphically intensive workload. For gamers, content creators, and visual effects artists, a powerful GPU is non-negotiable. The role of the GPU is even evolving within gaming thanks to AI. Technologies like NVIDIA's DLSS, Deep Learning Supersampling, and AMD's FSR, Fidelity FX Super Resolution, use AI to boost performance. They work by rendering the game at a lower resolution and then using a trained AI model, running on specialized cores within the GPU itself, to intelligently upscale the image to a higher resolution. This gives you the visual quality of a high-resolution image with the performance of a lower-resolution one. So the GPU is now not only rendering the graphics, but also using its own AI capabilities to make the game run even better. The NPU, on the other hand, is starting to find its own niche in the broader user experience, even on devices built for gaming and creativity like laptops. While the GPU handles the main event, the NPU can work in the background to improve other aspects of the experience. For example, on a video call or a game stream, the NPU can efficiently handle real-time background blur, noise cancellation for your microphone, or even track your eyes to maintain virtual eye contact with the camera. These are all AI-powered features that would otherwise have to run on the CPU or GPU, stealing resources from your main task. This creates a future where these processors don't just compete, they collaborate. Imagine a next-generation laptop where the CPU handles the operating system, the GPU runs your game at max settings, and the NPU manages all the smart AI features in the background without impacting performance. This division of labor is the key to creating more powerful and efficient devices. The GPU remains the master of pixels and visually demanding tasks, while the NPU becomes the master of smart, low-power background operations, creating a user experience that is better as a whole. Each processor just sticks to what it does best. So, after all this, which one is better? The truth is, it's actually the wrong question. The right question is, which one is better for a specific job? Let's break it down into a few key areas. For PC gaming, three-dimensional modeling, and high-resolution video editing, the GPU is the clear and obvious winner. There is simply no substitute for its massive parallel processing power when it comes to pushing pixels and rendering complex visual information. If your work or hobby is visually intensive and runs on a desktop or a powerful laptop, investing in the best GPU you can afford is the top priority. The NPU is largely irrelevant for these specific high-performance tasks. Now let's consider the world of AI. Here it gets more nuanced and really depends on whether you're training the AI or running it. For training large, complex AI models from scratch, the kind of work done by researchers and big tech companies, the GPU is still the champion. Training requires both massive parallel processing and the flexibility to experiment with new model architectures, and high-end data center GPUs provide the perfect blend of power and adaptability for this. This is the heavy-lifting foundational work of AI development, and it happens on GPU-powered servers. However, for running AI applications on personal devices, what we call AI inference, the NPU is the undisputed victor. This covers almost all the smart features on your smartphone, tablet, or modern laptop. Things like voice recognition, computational photography, and real-time translation are all inference tasks. The NPU can perform these tasks much faster and, more importantly, with significantly less power consumption than a GPU. For any battery-powered device where you want intelligent features without a massive drain on battery life, the NPU is the ideal solution. It makes on-device AI practical and efficient. For everyday computing, browsing the web, writing documents, watching videos, neither a high-end GPU nor an NPU is strictly necessary. The integrated GPU that comes with most modern CPUs is more than capable of handling these tasks. However, the NPU is starting to enhance this experience by powering small, helpful AI features within the operating system, like smarter search or suggestions. The future isn't about choosing one over the other, it's about devices that intelligently use the right processor for the right task: CPU for general control, GPU for intense graphics, and NPU for smart, efficient AI. So, to wrap it all up, the showdown between the GPU and the NPU isn't about one knocking the other out, it's about a veteran champion finding its role and a new, specialized contender taking over a specific part of the ring. The GPU, our graphics powerhouse, remains the undefeated champion of gaming, professional visual workloads, and the heavy-duty training of massive AI models. Its strength lies in its immense, flexible parallel processing power. If your digital life revolves around creating or consuming high-end visual content on a powerful machine, the GPU is, and will remain, your most valuable player. The NPU, on the other hand, is the champion of efficiency and on-device intelligence. Its rise is a direct response to our desire for smarter, more helpful devices that don't die after a few hours. By being purpose-built for AI inference, it brings the power of artificial intelligence out of the cloud and into the palm of your hand, running features on your phone, laptop, and smart home devices quickly and with minimal battery drain. If you value smart features, long battery life, and the privacy of on-device processing, then the NPU is the silent hero working for you. For the average person buying a new piece of tech, here's the bottom line. If you're a gamer, look at the GPU specs first. If you're a creative professional, look at the GPU specs. But if you're buying a new smartphone or a thin and light laptop and you see AI engine or NPU listed as a feature, you can now understand what that means. It means the device is designed to handle modern, intelligent features efficiently, leading to a better camera, smarter assistants, and longer battery life when using those features. It's a sign that the device is built for the future. Ultimately, the best-case scenario is a device that has both and uses them intelligently. The future of computing is specialized. It's about using the right tool for the job to achieve the best possible performance and efficiency. The CPU, GPU, and NPU are not rivals in a zero-sum game. They are members of a team, each with a unique skill set. Understanding their individual strengths doesn't just make you a more informed consumer. It gives you a front-row seat to the incredible hardware innovations that are powering the next generation of technology.